When we're solving these equations, again, has to have equal signs. Our first goal is let's get rid of all the fractions. The nice thing about this first problem is there's only one fraction, it's only got an x below it. So if we multiply every term by that x, we'll be done with fractions in the problem. Times x here, times x here, times x here. These go away, leave me with 8. 7 times x is 7x. 8 times x is 8x. My last step, I'm going to subtract 7x from both sides. That's going to leave me with 8 equals x, which is the correct answer. For problem 17, it's a little more complicated version of the same thing. I start out by factoring the bottom of this equation. 2 parentheses, x and x, bring down the positive. That negative tells me different from positive is negative. I'm looking for two things that multiply to 2 and subtract to 1. Only way to multiply to 2 is 1 and 2, so I put the bigger one there, the smaller one there. What that shows me is that in order to get rid of all these fractions, this has part of that in it. So all I need to do is multiply each part by this whole bottom, x plus 2, x minus 1. So here I do x plus 2, x minus 1, they both cancel, and just leave me with 2x. Here I do x plus 2, x minus 1. These two cancel and leave me with 2 times x plus 1. 2 times x gives me 2x. 2 times negative 1 gives me negative 2. What I did to the left, I also have to do to the right. So here I'm multiplying by x plus 2, x minus 1 as well. Rather than rewrite it as these parentheses or FOIL it out, I can just remember, well, that's what it originally was before I factored it. So this is going to equal to x squared plus x minus 2. If I combine like terms over here, I get 4x minus 2. This equals x squared plus x minus 2. I'm going to take everything to the right. So minus 4x plus 2 plus 2. What that's done is it allowed me to set it equal to 0. X squared didn't have anything to combine with, so it stays. Positive x minus 4x leaves me with negative 3x. Negative 2 and positive 2 goes away. So what I basically need to do is factor the right-hand side of the equation. I see an x comes out of both and leaves me with x minus 3. Now I need to say, how do I make either of these two factors 0? Well, to make this factor 0, I would plug in 0. To make this one 0, I would plug in 3. If you're ever not sure what makes a factor 0, take that factor and set it equal to 0 and solve. So if, for instance, I wasn't sure what made x minus 3 0, I could set up x minus 3 equals 0, add 3 to both sides, and get my answer of x equals 3. Final problem 18 is a word problem that is confusing when you first see it, but when you see the method, it's really just applying the same method every time. Basically, you want to figure out how much does each of the people who we're helping complete in a single unit of time. So in this case, we're trying to say how much of the field do they prep in 1 minute. The groundskeeper preps a full field in 45 minutes, so he has to prep 1/45 of a field. If I then look at his assistant, it takes him 65 minutes for the total field, so he does 1/65 of the field in 1 minute. Together, they complete some portion of the whole total job X. That total job is going to tell us how many total minutes it took them to complete everything. This is always the setup. 1 over the first time unit plus 1 over the second time unit equals 1 over x. Same way we did with the problems above, we want to multiply by a common denominator. Rather than worry too much about finding the perfect numbers, you can literally just multiply by the 3 bottoms. So if I multiply everything in this equation by 45 times 65 times x, what's going to happen is 2 things are going to stay, one's going to go away. So in the first one, 1 over 45, this 45 and this 45 will cancel, and I'll be left with 65x. For the next one, this 65 and this 65 will cancel, and I'll be left with 45x. Finally, with what they're equal to, this x and this x will cancel, and I'll be left with 45 times 65. Definitely want to do that in my calculator. So I'm going to turn on 45 times 65, gives me 2925. Last step, combine like terms on the left. 65 and 45 give me a total of 110x. And then finally, divide by what's in front of x to get to your final answer. When I put that in my calculator, 2925 divided by 110 gives me x equals 26.59. I'd absolutely accept that. If Cengage wants it as a fraction, I can always show you where the arrow frac button is on your calculator. But basically, if I want to use that, my calculator tells me this would reduce to 585 divided by 22.